Hello everyone. In the last lesson, we let the robot sort flanges and reducers by quantity. So, can we issue the number of sorting tasks on the HMI interface, and can the robot feed back the number of sorted workpieces to the HMI interface? The answer is yes. In this lesson, we'll complete this task. First, let's learn about GI group signal reception of FANUC robot number of sorting tasks. If the robot can receive the quantity of sorted workpieces issued by the staff, record the quantity of each sorted workpiece, and display them on the man machine interface. Then we can not only intuitively see the sorting data, but also continue to use this data as one of the bases for product quantity tracing and data statistics. Here, we focus on how to display the sorted workpiece number data to the main machine interface. We use Siemens HMI touch screen here. The main idea is that the FANUC robot can transmit the sorted workpieces quantity data to the Siemens PLC, and the PLC will then display the data on the touch screen. Next, please answer this question. What is the main purpose of introducing the group input signal GI and the group output signal GO in the integrated system of FANUC robot within device? A. Control the machine trajectory of the robot. B. Record and display the workpieces quantity. C. Adjust the accuracy of the within device. D. Monitor the running status of the motor. I will give you 5 seconds to think, and will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Okay, let's keep going. First, let's implement the first step, the data sending and receiving of FANUC robot. Here, we introduce the group input signal GI and the group output signal GO. GI is responsible for receiving data from the touch screen, and GO is responsible for sending data for displaying on the touch screen. The distribution interface of the group input signal is shown in the figure. The rack number of GI1 is 82. The slot number is 12. The starting point is 1, and the number of points is 8. According to the content of the previous chapter, we know that the signal of GI1 comes from the backfall DeviceNet I/O module, and the digital input terminals of the backfall DeviceNet I/O module are respectively connected to the Q0.2 to Q1.0 output terminals of Siemens PLC. Since Q0.2 to Q1.0 are not 8 consecutive points, we need to create a variable to remap addresses. First, add the variable gi1. The data type is US_int and the address is MB50. Create bool variables do 0.0 to 0.7 in turn, and the corresponding addresses are Q 0.2 to Q1.1. Second, create bool variables gi 1.0 to 1.7 in turn, and then corresponding addresses are M15.0 to 15.7. Third, assign the values of do 0.0 to 0.7 to gi 1.0 to 1.7 in order in the SCL program block. Next, please answer this question. What function is the GI signal responsible for in the process of transmitting the workpieces quantity from the FANUC robot to the Siemens PLC? A. Send the data and display them on touch screen. B. Receive data from a touch screen. C. Control the output of PLC. D. Monitor the running status of the robot. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Okay, let's keep going. The distribution interface of the group output signal is shown in the figure. The rack number of G01 is 48. The slot number is 1. The starting point is 109. And the number of points is 8. They are connected to the I0.0 to I0.7 output terminals of Siemens PLC through hard wiring. The addresses of I0.0 to I0.7 are continuous and do not need to be remapped. We add variables in Bluetooth software. G01 data type is US_int and the address is IB0. Finally, the corresponding I/O domains is associated with the touchscreen software, and the data sent by the robot terminal G01 can be displayed in the receive edit box. Write the data in the send edit box and then send it to GI1 of the robot. Next, please answer this question. Which of the following is true regarding the description of the GO signal? A. The GO signal is connected to the PLC through soft connection. B. The number of points of the GO signal can be customized on the distribution interface. C. The GO signal is responsible for displaying data to the touch screen. D. The GO signal is connected to the discontinuous address of the PLC through hard wiring. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's look at one more question. What operation needs to be performed on the touchscreen software in order to display the workpiece quantity data sent by the robot side on the touch screen? A. Write SCL program blocks. B. Remap the address of PLC. C. Associate the corresponding I/O domain. D. Configure bake-for remote I/O module. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Next, we learn the GO group signal sending of FANUC robot, the workpieces quantity that have been sorted. Please focus on the program segment in the right box. We enter the total quantity of flange workpieces to be sorted on the touch screen, and this value will be transmitted to GI1, which will then be assigned to R11. Then add a tag LBL1 as the jump marker position. The cumulative value of the flange workpieces quantity is in R9. Assign the data in R9 to GO1. GO1 is transmitted to PLC, and then the data value can be displayed on the touch screen. Next, for every flange we obtain, we have to subtract the value in R11 by 1 until the data in R11 is less than or equal to 0. The whole cycle stops. Alright, in this lesson, we realized task assignment and sorting data display through the group GIGO signal and the HMI interface of the FANUC robot, which strengthened the system integration capability. That's all for this lesson. Thank you for watching.